Good morning, children. Today I am teaching about atoms and molecules lessons, some important questions. The first question, relation between vapor density and relative molecular mass. This is important 5 more questions. Listen. The first, the definition for relative molecular mass is the ratio between mass of one molecule of a gas or vapor to the mass of one atom of hydrogen. So to calculate the mass of the atom, and the definition for vapor density is the ratio between the mass of a certain volume of a gas to the mass of an equal volume of hydrogen. So at the condition of same temperature and pressure. The first one, the equation for vapor density is equal to mass of a given volume of a gas at STP divided by mass of the same volume of hydrogen. The first we consider that number of molecules in one volume is equal to n. So this is equation to consider given volume is equal to n. So n molecule of gas. So rewrite the equation vapor density is equal to mass of n molecules of a gas or vapor at STP divided by mass of n molecules of hydrogen. Now we consider n is equal to 1. So n consider for number of molecules. So now I am considered for n is equal to 1 molecule. So vapor density is equal to mass of 1 molecule of a gas or vapor at STP. STP means standard temperature and pressure divided by mass of 1 hydrogen molecule. So listen students, hydrogen molecule means in atom we have to present for only one atom present in the element means this is called for atom. Suppose the two atoms are present in that particular element, that element is called for molecule. So hydrogen molecule is equal to H2. It is a symbol for hydrogen molecule H2. So the H2 is considered two atoms are present in the hydrogen molecules. So I have to rewrite that equation. Vapor density is equal to mass of one molecule of a gas at STP divided by mass of two atoms of considered hydrogens. So புரிஞ்சுதா, mass of one hydrogen molecule அப்படிங்கிறது தான் நான் என்ன பண்ணியிருக்கேன், mass of two atoms of hydrogen அப்படின்னு சொல்லி நம்ம என்ன பண்ணியிருக்கோம், ரைட் பண்ணியிருக்கோம், எழுதியிருக்கிறோம். So next one, taken out the 2, number 2 taken out outside, vapor density is equal to mass of one molecule of a gas at STP divided by 2 into mass of 1 atom of hydrogen. இப்போ இங்கேருந்து 2ங்கிற நம்பரை நான் அவுட் சைடில் எடுத்துட்டேன் அப்படின்னா இங்கே வந்து 1 அப்படிங்கிற நம்பர் ப்ரெசென்ட் இருக்குது அப்படின்னு சொல்லி நம்ம கன்சிடர் பண்ணிக்குவோம். ஸோ அதனால் நான் என்ன பண்ணியிருக்கேன், 2 into mass of 1 atom of hydrogen. So relative molecular mass is equal to, already know the relation, relative molecular mass is equal to mass of 1 molecule of a gas divided by mass of 1 atom of hydrogen. So look at the equation vapor density. This is an equation for looking like relative molecular mass equation. So கவனிங்க, இந்த 2ங்கிற நம்பரை 1/2 அப்படிங்கிறத நம்ம அவுட் சைடில் எடுத்துட்டோம் அப்படின்னா, காமனாக வெளியில் எடுத்துட்டோம் அப்படின்னா இந்த ஈக்குவேஷன் பார்க்குறதுக்கு எப்படி இருக்குது, ரிலேட்டிவ் மாலிகுலர் மாஸுடைய ஈக்குவேஷன் ஃபார்மேஷனில் இருக்கனால நான் என்ன பண்ணியிருக்கேன், அதாவது ரிலேட்டிவ் மாலிகுலர் மாஸ் கம்பேர் பண்ணி நம்ம என்ன பண்ண போகிறோம், எழுத போகிறோம். ஸோ வேப்பர் டென்சிட்டி இஸ் ஈக்குவல் டு ரிலேட்டிவ் மாலிகுலர் மாஸ் டிவைடட் பை 2. ஸோ புரிஞ்சுதா, வேப்பர் டென்சிட்டி ஈக்குவல் டு ரிலேட்டிவ் மாலிகுலர் மாஸ் டிவைடட் பை 2. ஸோ இந்த 2வை மட்டும் விட்டுட்டு பார்த்தீங்கன்னா இந்த ஈக்குவேஷன் எப்படி இருக்கும், ரிலேட்டிவ் மாலிகுலர் மாஸ், ஸோ டிவைடட் பை 2, தென் ஈக்குவல் டு 2 into vapor density is equal to relative molecular mass. So understand, first one equation for vapor density is equal to that mass of given volume divided by mass of same volume. Then again the given volume is present instead of n. So n is a number of molecules divided by n molecule of gas. Now I consider n is equal to 1. So 1 molecule of gas divided by mass of 1 hydrogen molecules. So hydrogen molecule means 2 atoms are present in the particular hydrogen element. So you have to write for 2 atoms of hydrogen. So the common number 2 that taken outside that equation. So you have to rewrite that equation mass of 1 atom of hydrogen. This equation is looking like for relative molecular mass equation. So I will rewrite that equation. Vapor density is equal to relative molecular mass divided by 2. So that the proof that the statement relation between vapor density and relative molecular mass நம்ம என்ன பண்ணிட்டோம் இப்போ find out பண்ணியாச்சு. இது வந்து ஒரு important 5 mark questions. So next one, the next questions, some important 2 mark questions. Okay, very very important. Listen. First one, what is the meaning of monoatomic molecule? So an atom is present in that particular element. That atom is considered for the element is monoatomic, diatomic and triatomic. The first one, monoatomic molecule. So the single atom is present in the element, that is called for monoatomic molecules. Example, hydrogen, nitrogen, chlorine and K for potassium. Okay, so hydrogen, nitrogen, chlorine is for single number. So suffix la enna irukku artham 1 nu irukku artham. So single atom is presented to the particular element. That element is called for monoatomic molecule. Then second one, diatomic molecule. So there are 2 atoms are presented in that particular element. That is called for diatomic molecule. Example, H2, N2, Cl2 and potassium bromide. KPR means potassium bromide. So H2 means 2 hydrogen atom presented. N2 means 2 nitrogen atom is presented in the molecule. Cl2, 2 chlorine atom. This is for potassium and bromine. The 2 different atom is presented in the element. So that is called for diatomic molecule. The next one, triatomic molecule. 3 atoms are presented in the element. That is called for triatomic molecule. Example, H2O. This compound presented for 2 hydrogen atom and 1 oxygen atom. So added for 3 atoms are presented in the particular element. So that is called for triatomic molecule. Next one, CO2. CO2 means carbon dioxide. So 1 carbon atom and 2 oxygen atom is presented for CO2 molecule. That is called for triatomic molecule. So okay, the next one, isotopes, isobar and isotones. This is for important 2 mark questions. Okay, the same concept but different meanings. Okay, so isotopes means same atomic number but different mass number. So look at that element, 17, chlorine 35. So the chlorine presented for superior number 35 is called for mass number. The suffix presented 17 is called for atomic number. So looking like the 2 chlorine element, chlorine 1735, chlorine 1737. So look at the 2 element, the atomic number is same but mass number is different. That is called for isotopes. The next element means argon and calcium. Ar for argon, Ca for calcium. So look at the 2 element, argon and calcium. The atomic number is different but mass number is same, 40 and 40. So same mass number but different atomic number means that is called for isobars. The next one, isotones. Look at the 2 element, carbon and nitrogen. C for carbon, N for nitrogen. So atomic number 6 and 7, mass number 13, 14. So look at the 2 element, atomic number is different and mass number also is different, but the number of neutron counting is same for 2 element. That is called for isotones. Now you have to calculate for neutron number. How to calculate the neutron number? The mass number minus atomic number. You have to subtract mass number from atomic number, then we get the neutron number. So 6 carbon 13. So you have to calculate for neutron number. 13 minus 6 is equal to 7. Then you have to calculate for a neutron number for nitrogen element. 14 minus 7 is equal to 7. So okay, then look at the 2 element, the 7 and 7 is presented, the same number of neutron is presented.